So this is section 9.4, properties of logs. Here are the rules. There are 4 rules that we're going to start out with, and you must have them memorized. The first rule is called the product rule, and it's when you have the log base anything, we'll call it base A in this case, of 2 things being multiplied together. So here we have log base A of m times n, and the property of the product rule says we can now expand that, and wherever it's multiplying we can split those into individual logs and add them. So it's not actually distributing, but you end up with 2 logs as opposed to 1. And this is very useful if you know, say you have the log of 10, but you know what the log of 2 and the log of 5 are. You could split it into the log of 2 plus the log of 5 and then add them separately then, if you didn't have your calculator to calculate the log of 10. The power rule says the log base A of m to the, say, p power moves the exponent out in front and turns it into a leading coefficient. So it's now p times log base A of m. So that exponent just moves out in front and multiplies times the log. The quotient rule, log base A of m over n, is very similar to the product rule, where here when we were multiplying, we then added the logs, and here we are dividing, so we are going to subtract the logs. And the base rule says if you have log base A of A to the something, so if this base and this base are the same number, that whole thing cancels and your answer is just k. For example, a good example of this is log base, say, y of y. Well, the exponent here on this y would be your answer, k in this case, which is a 1. So that just equals 1. You will see this a lot, and this just simplifies down to 1. Okay? So please pause it if you need to get these rules all copied down. They are in the book and on Math Excel as well, but they're very important. So the first thing we're going to do is just rewrite equivalent expressions. So number 1 says the log base 2 of 4 times 16. Well, you have 2 things being multiplied, so ask yourself which rule are you going to use, and you are going to use the product rule and break it up into 2 different log base 2s. These bases always stay the same, and it's the log base 2 of 4 and the log base 2 of 16. And if you go back up to these rules, they were being multiplied, so now you add them. And that's simplified. And you can also ask yourself, okay, this is a base 2, so if I look back at this shortcut here, if I have the same number and the base and the big base, for example, log base 2, if I turn 4 into 2 squared, this base and this base are the same. These cancel and you're left with 2 plus, and here's the log base 2 of 2. A 16 is 2 to the 4th. So this 16 got replaced with 2 to the 4th. These 2's cancel and you're left with 4. 2 plus 4 is 6. So this is how you can simplify something that you may not have known the log of 4 times 16 base 2, but now it is just 6. And you can check that in your calculator as well if you'd like. So take a moment, try log base b of 7 plus log base b of 5, and go ahead and simplify that going backwards using the product rule. Okay, so you should have log base b of, because they're adding, we can condense them and multiply, is 7 times 5, which is log base b of 35. So this is your final condensed answer. Number 3, log base A of 9 to the negative 5th power. Pause it, think about which rule you're going to use. Okay, you should be using the power rule, which brings the negative 5 in the front and multiplies it times log base A of 9. And then that's simplified. If these were the same, A and 9, they would cancel into 1. It'd be negative 5 times 1, but in this case they're not. Number 4, log base 7 of cube root of x. Well, that's log base 7. Cube root of x is also x to the 1/3, if you recall back from our exponent chapter. And now that you have an exponent, this problem is just like number 3, where you can move it out front. And you get 1/3 times log base 7 of x. Okay, number 5, log base t of 6 over w. This is two things being divided, the 6 and the w, so you will use the quotient rule. So we have log base t of 6, and the quotient rule then subtracts them, minus log base t of w. And then that is simplified, or expanded. Sometimes you'll see problems that say expand or condense. Number 6, log base b of 17 minus log base b of 34. Go ahead and try that for a moment. You should see that because they're subtracting, you can rewrite that using the quotient rule, and you have 17 over 34. And that does reduce, so we have log base b of 1/2. So there's a few problems, but they're pretty quick, but you have to get used to all these rules. You must know all the rules for the test. Okay, here's specific examples then to expand. Before we were just using the rules to kind of go back and forth. So now we are strictly expanding. So my initial problem, log base b of x cubed over y times z in the denominator, so write that down. So the first thing I'm going to do is use my quotient rule to split this up. So I know I'm going to have log base b of x cubed minus log base b of yz. And now your next step, we can simplify this first one using the power rule. The exponent comes out front. So that's totally simplified. Minus, and now here we have a product rule inside of this. So put the whole thing in parentheses if you'd like to split them up. And you can add them. Now, you'd be fine leaving an answer like this, but if I were you, I would just distribute that negative. They're both correct, but I'm going to use this to show you the shortcut that I would use. Okay, so this is your final answer if I distribute the negative. Right from the beginning here, I would skip this step when you get better at this, because I would just say log of x cubed minus log of y. And because this z is also in the denominator, I would also say minus log of z. So right there I would say 3 log x minus log y and minus log z, because they're both in the denominator. You can do that. Okay. So log base a, a 4th root of xy over z cubed. So let's go ahead and look and see where we want to start. The first thing is I would probably get rid of the radical, and I would say log base A of this whole thing, xy over z cubed to the 1/4 power. That's what fourth root is. And from here you have a couple choices. You could go through and distribute the 1/4 to all the terms, or you could leave 1/4 out in front of the log and then split it all up and then distribute. I do think it's easier to just change this to x to the 1/4, y to the 1/4 over z to the 3/4. I just distributed the 1/4 to all the terms. So now we have log base A of x to the 1/4 plus log base A of y to the 1/4 minus log base A of z to the 3/4. And then just go through and move all your exponents out front. And I think that's a lot faster than if you were to change this to log of x plus log of y minus log of z cubed and then take the 1/4 to all of that. So that's just my hint to you. So now let's go the other direction and condense. We have 1/2 log of A, log base A of x minus 7 log base A of y plus log base A of z. Now notice all these bases must be the same in all these problems for you to be able to combine or expand these. But if you do see them separate, you got to leave them separate. So condense just means to put it back into one log. The trick is you know that you've condensed all the way when you only have written the word log one time. So we'll go step by step. First, we'll take care of this. The power rule says this coefficient comes up as an exponent. Minus log base A of y to the 7th plus log base A of z. Now, just like before, we're going to write log one time, but this is a positive in front, so it's on top, just like our exponent rules. This is a minus, so the y to the 7th goes on bottom. This is a plus, so it's back up to the top. So it's log base A, you write it one time, of the top stuff is on top, all the things added and all the things subtracted are on bottom. You could also write that as square root of x times z if you'd like. It doesn't matter. Okay. Log base A of b over square root of x plus log base A of square root of bx. So what we're going to do is we know that they're adding, which turns this into multiplying. So we're going to have the top has a b and square root of bx is on top. When you multiply something, it's on top. Square root of x is on bottom. This little piece here, you can write this as split these into their own square roots if you'd like. And it's helpful in this case because we have a square root of x in the denominator. So now those do cancel. So we're left with log base A of b times square root of b. And b is to the first, and square root of b is to the 1/2. And what do you do with exponents of the same base? You add them. So we have log base A of b to the 1 plus 1/2 is 3/2. And if you'd like to simplify that, you sure can, and move the 3/2 out front using the power rule. And that would be the best final answer, although I would accept that on a test. Okay, so now we only have a couple left. I'm giving you two circumstances. I'm telling you, say you don't have a calculator, and I'm telling you log base A of 2 is 0.431 and log base A of 3 is 0.683. I want you to find log base A of 6, log base A of 2/3, and log base A of 2 times A. Now you can't do this without knowing this information because of the base A in there. You don't know what number that is. But I do know 6 is consisted of a 2 times 3. So if I have the log of 2 times 3, then I can rewrite that as the log of 2 plus log base A of 3. And then you have log of 2 is 0.431 plus log of 3 is 0.683. And if you add them, then you just get 1.114. So here's the hint here. You would just use the quotient rule. And I'll get you started here. Log base A of 2 plus log base A of A. Go back to your rules if you forgot what happens here. I need you to finish those. I will be checking them. And the last thing, there's a couple little short ones I'd like you to solve as well. 12 and 13. Now here's one hint. If there's no base number here, no base number means it's a base 10. Base 10 is the implied number. You don't need to type that in your calculator. Your calculator will recognize that. So that's it. Finish these up, please.